वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल स्टडी द हाइड्रोकार्बन चैप्टर ऑफ क्लास 11th। हाइड्रोकार्बन of class 11th. So let's start with the alkane. So alkane is what? Alkane we have, as you know, alkane is the CnH2n plus 2. So this is the molecular formula of alkane, and the suffix we use, that is ane. Suffix ane. So suppose n is equal, n it have only single bond. So n will start from 1, 2, 3, 4, 5. It may be anything. As you know about the word root. So word root is what? Word root, I just like to introduce you once more. 1 carbon is known as meth, 2 carbon is known as eth, 3 carbon is known as prop, 4 carbon known as bute, 5 carbon known as pent, 6 carbon is known as hex, 7 carbon known as hept, 8 carbon known as oct, 9 carbon is known as non, and 10 carbon we have the decane. So dec. So now this is the word root, and the what it comes before after word root, that is the suffix, and before word root is known as prefix. So as in this case of alkane, we are using the suffix. So suppose we put n is equal to 1, so it will be C1H2 into 2 plus 2. This will be CH4, and this is 1 carbon, that's the meth, and we use suffix ane, methane. So this is the methane. This is on the molecular formula. Now if you want to write the structure formula of methane, so a structure formula can be written as, it have tetravalency, so 1, 2, 3 and the 4 is satisfied. So this is your methane. In the similar way, if you want to move towards the ethane or butane or the propane or the octane, you can give the name accordingly. Now let us give some IPC name of branch chain alkane. Like we have CS3, CH, CS3, CH2, CH2, CH, CH2, CH3, and the CH2, CH3. So what the name of this compound will give according to the IPSC. Similarly, we have some more, like we have CH3, CH2, 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 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4. We put over here molecule just like this. C, CH3, CH3, and the CH3. So I just give the IPC name of these molecules. So let's start. We have 3 laws about the IPC nomenclature. First is longest chain rule. Longest chain rule. So you have to find out the longest chain first. Secondly, you have to find out lowest locant rule. Lowest locant rule. Lowest locant rule states that whatever the branched alkyl group which have not named, that will be counted from the lowest number. And third one, we have the lowest sum of locant rule. Lowest sum of locant rule. So if substituents are more than 2, then we have to sum up, and we have to find out the way, or we have to find out the end towards that it comes at the lowest position. Let's take the example of this compound only. So this is we will start from this side. 1, 2, 3, 4, 5, 6, 7. 7 is the heptane. So we just write the heptane over here. Now at second position, this is the methyl, and at fifth position this is ethyl you have. So we write alphabetical. You should also keep in mind about the alphabetical order. So alphabetically you have to put the substituent at their position. So at fifth position this is ethyl. So first we write 5-ethyl. Wait a second. This is 5-ethyl, and at second position 2-methyl heptane, isn't it? So now in this case we have to find out the longest chain. So 1, 2, 3, 4, 5, 6 and 7. 7 is the heptane. Now how you just give the name of this substituent. So whichever the carbon is attached to this fourth carbon, we will start counting from that with the longest chain again. So is 1, 2, this is the longest chain. So we just write, at the fourth position we'll just make a big bracket, and it is a 2 carbon, so we just write ethyl over here. Why ethyl? Because this is attached to this one also, so we just write, not in place of ethane we just write ethyl. And at second position there is 2-methyl, which we have not named, so it is 2,2-dimethyl ethyl heptane. So this is the IPSC nomenclature. So now let's move towards the isomerism part. What type of the isomerism is shown by alkane. If you want to see the isomerism, then you can see my video which is in playlist, so you can also see the isomerism over there. Now here the in case of isomerism of alkane, what type the isomerism of alkane have? So it have chain isomerism. What the isomerism? Chain isomerism. So what the characteristics of the chain isomerism? So the molecular formula will be same, but the structure will be, structure formula will be different. Why the structure formula will be different? Due to chain. So let's move. I just like to give you one example over here. So like this is 1, 2, 3, 4, 5 carbon in a straight line, straight chain. So this is the N-pentane. We say is the N-pentane. Oh, this is alkane. So N-pentane. Now, if there is a branching, from the any middle carbon. So if there is a one branching from the middle carbon, it is known as iso. So it is the isopentane over here. And if it is two branching from the middle carbon, so this will known as neopentane. So this is about the isomerism of alkane. Now what's about the we will also discuss about the benefit or the merit of the due to the branching. So this is directly related to the boiling point, which we will discuss about this later on. Now I just like to give you some more thing, like what is, like in case of heptane, this is in case of pentane, there is how many possibility? There is one more possibility of the iso, so it can be over here. So it is the 4 possibility of isomerism in pentane in the case of 5 carbon alkane. Now in the 6 carbon alkane like heptane, how many possibility? Just solve it and tell me. So it will be 9. It will be 9 isomerism possible for heptane, 9 chain isomerism possible for hectane, and for octane how many it is possible? So you have to work out over here. So you will get it's 18, and for nonane you will get it 35 isomerism possible for the nonane. And for decane how many isomerism is possible? And that is the 75 isomers is possible for decane. So this is a very interesting thing you should keep in mind. Now let's just move towards the structure of alkane. structure of alkane. So basically alkane it looks like is a tetrahedral structure it have. Now if you find out the hybridization of alkane, the hybridization is hybridization. So what's about the hybridization of alkane? So since it have all, if it is only single bond over here in a molecule, then it is the sp3 hybridization. If there is one double bond between two carbon, that is the sp2 hybridization. If one triple bond is present over there, then it is the sp hybridization. Or is the two consecutive double bond is there, then it is also the sp hybridization. Now hybridization in the case of alkane is what? sp3. So this is the sp3 hybridization. Now so what the shape? The shape it have the tetrahedral shape. Tetrahedral shape. The geometry is the same, the tetrahedral. So it looks like how, like in the case of methane, this looks like just like this. So this is methane is tetrahedral. Now it have the different structure. We have this is the tetrahedral. We have also have the three-dimensional structure. If we just draw just like this, this is just like this is left, this is right. One is known as a vase, other is known as a dash. So this is vase is just like this, it towards the viewer, and the dash is just away from the viewer. This is away from the viewer. So this is and this is left, this is the right, this is towards the viewer, this is the vase, and this is dash, and this is away from the viewer. So this is also this is the three-dimensional structure, 3D structure. Yeah. So some more structure is possible. We have another 3D view, you can say. So it is only the vase and dash. Vase away from the viewer. Vase. This is known as the vase. This is away from the viewer, and the dash. No, this is the dash away from the viewer, and this is vase. This is towards the viewer. This is towards the viewer. So this is also the dimension. Now we have also that this is a three-dimensional structure, and we have also the two-dimensional structure. Two-dimensional structure, like we just simply write like this. So this is what, this is the two-dimensional structure. So now have a look here. Now we just move towards the methods of preparation of alkane. So how we just prepare the alkane? So we just write over here methods of preparation of alkane. So how many methods of preparation of alkane we have? So we will just discuss about that one by one. Then from first one is from alkyl halide. From alkyl halide. So we can get alkane from alkyl halide. Now, so how you can get alkane from alkyl halide? So first we can get it from Grignard reagent. From Grignard reagent. So what's about the Grignard reagent? Grignard reagent is alkyl magnesium halide. That is the RMgX. So this is known as alkyl magnesium halide. So this is alkyl magnesium halide. This is your Grignard reagent. Now how it will took place? So first the Grignard reagent undergoes hydrolysis. So when it reacts with the water, it will form alkane. How? Have a look here. First we have to understand how you just prepare the Grignard reagent. So Grignard reagent can be prepared with the alkyl halide. When alkyl halide reacts with magnesium, in presence of dry ether. In presence of dry ether, it forms RMgX. This is your Grignard reagent. This is your Grignard reagent. Now this Grignard reagent will react with the water. So like RMgX plus H plus, water is H plus OH minus. Now in the similar way we have, like this is slightly negative charge, this is slightly positive charge. So the positive will get attached with the negative, negative will get attached with the positive. So R minus will get attached with the H plus, so it will give you RH. That's the alkane plus MgXOH as a byproduct. Nah? So this is your alkane. RH is your alkane. Now I just like to give you some example. So now if ethyl magnesium bromide, if you take ethyl magnesium bromide or methyl magnesium bromide react with the water, like H plus and the OH minus, again here the negative, here the positive, and positive will get attached to the negative, negative will get attached to the positive. So it will be CH4 over here plus this will be MgBrOH as a byproduct. Huh? Similarly, we can make some other one. Right. One more thing is over here with the Grignard reagent when react with the alcohol. So it also gives alkane. So suppose we just take the Grignard reagent like CS3 Mg I, and it will react with the CS3 OH. Nah? So again the charges will develop accordingly. So this is the negative charge, this is the positively charged alkyl group. But here in this case of Grignard reagent, alkyl group is more electronegative than it is negatively charged, and magnesium is less electronegative, so it is a positively charged. So now this negative will get attached with the positive, and this positive will get attached to the negative. So your product will be CH3, that is the ethane plus MgOIOH. So this is very important information about the Grignard reagent. Then in case of Grignard reagent, alkyl group is always negative because carbon is more electronegative than magnesium. So you should keep in mind. So this is the first method of preparation of alkane and from alkyl halide, that's from Grignard reagent. Now we'll just move to the next one. Next one is a name reaction, that's on the Iit-Jee reaction, WRTZ, Iit-Jee reaction. So what's about the Iit-Jee reaction is, so when two molecules of alkyl halide react with a sodium metal in presence of dry ether. So two molecules of alkyl halide like this react with sodium metal in presence of dry ether. So what will happen? It will form higher alkane. 2NX will out from here. 2NX is out, and RR will get attached. So it will form higher alkane. So this is Iit-Jee reaction is very convenient for the preparation of symmetrical alkanes. Nah? So it is not so convenient for the unsymmetrical alkanes. Symmetrical or unsymmetrical is what? And why it is preferred for the symmetrical alkane. What is the meaning of symmetrical alkane and unsymmetrical alkane? Now if the alkyl group on the both side is the same, so it will give you the symmetrical alkane. But if the alkyl group on the both side is different, as in the case of, suppose we just take the RX plus 2Na plus R dash. So here in this case R and R alkyl groups are different. So this is not preferable for the preparation of alkanes. Why this is so? Because it will give you the mixer product. because when you take the alkyl halide, so we don't take the one molecule of alkyl halide. We take a number of molecules of alkyl halide. So there is three possibilities of formation. Three types of alkane can be formed from these two different types of alkyl halide when it reacts with the sodium metal in presence of dry ether. How? Have a look here. So suppose the first, as you know, this can form 2NaX, and it will form R dash plus 2NaX. Now, but there is some. This is the first possibility. Second possibility is what? So many alkyl halides, same type of alkyl halide. I told you because we don't take only one molecule, so we take the number of molecules over there. Number of molecules of Rx is over there. So they may combine to each other with the sodium, and they can form the alkyl of this type, RR type, and 2NaX. And there is one more possibility. What that one? This R-X will get combined to the sodium, and they can form R dash type of alkane with a 2NaX. Now what happens? Now we can't get a proper alkane from the unsymmetrical with a different type of alkyl halides with a sodium metal. So that's why this is not preferential, that different type of alkyl halide or unsymmetrical alkyl halide taken in the Iit-Jee reaction. So Iit-Jee reaction is very important. This is the name reaction. Now I just like to give you some example, but before that, mechanism is important. So how the reaction proceed? So I'm just giving a mechanism, then I'll just give you some example. So mechanism of Iit-Jee reaction is what? Have a look here. So what happens in the step 1? So it completes in 2 steps. Then step 1 is what? In step 1, when alkyl halide react with the sodium, then it forms alkyl sodium. Alkyl sodium is what? This is alkyl sodium plus NaX. NaX is out, because we take the 2 Na, so NaX is out, and 1 is NaX is out, and it form Rna plus, that is the alkyl sodium. Now in step 2, and this is basically organometallic compound. Organometallic compound is what? If the alkyl group have the metals combined with the metals, then it forms organometallic compound. So in first step it forms organometallic compound, and this is the alkyl sodium. What do you say this? This is your alkyl sodium. Alkyl sodium. Now in step 2, through intermediate formation of free radical. So what will happen when the Rx will combine with the basically this is the different methods we are using, not the step. We can't say the step 1 and step 2. The first one, this is the first method we can say. Now this is the first method, not the step 1 in place of step 1 and step 2. It's not removing. Wait a second. Yeah. So method 1 we can say, method 1, which so this will get combined and wait a second. Step 2 is not removing easily. Now it's removed. Now, so as it forms alkyl sodium, then this alkyl sodium will get combined. This alkyl sodium, we can say step 1 and step 2 for the method. Method 1 for step 1, step 2. Step 1, and this is step 2. Now, so Rna plus again we take the alkyl halide. Now in this case, as you know, this is the positive charge, this is a negative charge because this is more electronegative. So this Na will get combined with the X, and R will get combined with the R plus NaX is out. So this is one method And second method we have like we can form it by the formation of intermediate formation of free radical. Now method 2. Now so what happens in this case, alkyl halide when react with the sodium, then it forms a free radical. Free radical of sodium. Free radical means alkyl halide, alkyl group having odd electrons, that is a free radical. So it will form a free radical. This is your free radical. Free radical. And what happens in the next? This free radical will get combined to each other. Free radical will get combined to each other to form higher alkane. So this is the method 2. This is step 1 and step 2. Step 2. Now for them, this is 2 method supposed to be given for the Iit-Jee reaction. Now have a look. I just like to give you some example, so you will able to. Here the question number 1 I am just giving. What happens when simply we can write bromoethane. What happens when bromoethane it reacts with the sodium metal in presence of dry ether? So bromoethane is what? C2H5Br plus 2Na plus Br C2H5. So it will give you 2NaBr over here. So 2NaBr is out and it will form C2H5. C2H5 means and plus 2NaBr. So it is the 4-carbon alkane. Is the 4-carbon alkane is the butane we have. So this is about the Iit-Jee reaction. Now we'll just move to the next method of preparation. That is the Corey's-House reaction. Corey's-House reaction is also applicable for the unsymmetrical alkanes, which is restricted in Iit-Jee reaction. But in Corey's-House, we are discussing about the Corey's-House. Corey's-House is also the name reaction. Corey-House reaction. So Corey's-House reaction is applicable for symmetrical as well as unsymmetrical. Unsymmetrical and symmetrical alkanes. Symmetrical alkanes. This is applicable for the both one. Where the unsymmetrical alkanes were restricted in Iit-Jee reaction because with the help of through the Iit-Jee reaction it forms a mixture of alkanes, so that was not a proper reaction. But in the case of Corey's-House reaction, we can get the symmetrical or the unsymmetrical alkanes easily. Have a look here how. So first the alkyl halide will get react with the lithium and in presence of dry ether, so it will form alkyl lithium plus lithium halide. 2 lithium, 1 lithium will get combined to form halide, 1 ether. So this is your alkyl lithium. Now again what will happen? So this alkyl lithium will get combined with the copper iodide to form what? To form dialkyl copper lithium. So this is the lithium dialkyl copper, we can say lithium dialkyl copper. Lithium dialkyl copper. And plus what will happen? Lithium iodide is out. So now in the next step, this dialkyl, this lithium dialkyl copper will further get react with the other alkyl halide, other type of alkyl halide, and in this case what happens, lithium halide is first out. This lithium halide is out. So lithium halide is out, and this R will get combined to the copper. So this lithium is out, is a negative charge, and this R will get combined with this R dash. So is R dash. This is a different type of unsymmetrical alkane, we can say. R dash also may be the similar alkyl group, so it also represents the symmetrical alkanes too. So it will also give you what? RCU, that is the alkyl copper. So main product is the RR dash, where RR dash may be similar or the different alkyl group. So if the similar alkyl group, then it will give the symmetrical alkane, and if the dissimilar alkyl group, it will give you unsymmetrical alkane. Getting the thing? That's good. Now I just like to give you some example over here. So example is like as in the case of, I can give you some example like this. CH3 CH2 Br react with the lithium in presence of dry ether. So it will give you what? CH3 CH2 Li plus LiBr. Now again two molecules of CH3 CH2 Li plus CuI, it will give you what? It will give you lithium diethyl copper. So CH3 CH2 Cu. Here the Cu just right. Wait a second. It's not reading properly. So CH3 Cu CH3 CH2 whole twice Cu Li and plus lithium iodide. Iodine is over, so lithium iodide. And next is the CH3 diethyl lithium diethyl copper will again combined with the, suppose we just take this the 2 carbon halide. Now I take the 3 carbon halide. 3 carbon halide is what? We just take CH3 CH2 CH2Br, and then what it will give you? So it will just like this, it will get combined to this one. So your product will be CH3 and this will be your CH2 CH3 and plus CH3Cu plus LiBr. So this is a 1 2 3 4 carbon, that's a butane is formed. So this is your butane. Now so this is your butane. I think I did a little mistake over here. So I have taken over methyl over here. Basically this is ethyl CH2CH3. So you have also to take CH2CH3. So your product will be what? It will be ethyl copper CH3CH2 Cu, and this will be the product, not will be butane, it will be pentane, because it's a CH3CH2 and this 3 carbon is over here. So 1 2 3 4 5 is pentane. So pentane is a normal pentane. You got it? Now, so this is the mechanism of Corey's house reaction. Now just move to the next method of preparation of alkane. So what the next method is? So we can also prepare it by reduction of alkyl halide. So when alkyl halide is reduced, suppose this is the, we can say reduction of alkyl halide, reduction of alkyl halide. So how it will form by reduction of alkyl halide? So either you can make a reduction by dissolving metal. So reduction by dissolving metal such as zinc and CH3COOH or HCl or zinc copper couple, and alcohol. So we just take the alkyl halide, and this is your zinc and the HCl, so it will give you RH. RH means alkane. So these are the reducing agent, then this provides the hydrogen. So like this one, or simply we can write just like this, like I just like to give you some example, like when CH3 CH2 Cl will combine with this one, so we can put the hydrogen over here in presence of zinc, copper and alcohol. So what will happen? So it will give you CH3 CH3 plus HCl is out over here. So this is your alkane. This is 2-carbon ethyl halide, ethyl chloride, and it will give you ethane. It will give you ethane. Now, so this is the reduction of alkyl halide. Now, catalytic reduction is also there. So catalytic reduction. So reduction in presence of some catalyst. So what the catalyst we will use over here? So we can use some catalyst like palladium, carbon, or we can use platinum is also there. So basically nickel, Ranny nickel is a very reactive nickel, so it is also useful over there. So I can give you some example directly. So like suppose you take the methyl bromide, with it is reduced with the nickel platinum or Ranny nickel. So it will HBr is out, and it will give you CH4 plus HBr. Further, more oxidation, more reduction can take place. So when alkyl halide is reduced with the hydrogen iodide and red phosphorus, so it also gives the reduction by hydrogen iodide plus red phosphorus. So it also reduces alkyl halide into what? At 423 Kelvin. So it will also reduces. So HX is out, and it also I2 is out from here. You have to take alkyl iodide over here because we are using hydrogen iodide. So I2 is out from here, and it will give you alkane plus I2. So I can give you some example, like we have like CS3I plus HI in presence of red phosphorus. So what will happen? So this iodine, 2 iodine is out, and this is CH3 and 1 hydrogen 4, CH4 plus I2 is removed. Got it? So this is next method of formation of alkane by reduction. Now there is one more way we can reduce it. So what the way is? So we can also reduce it by using some chemical reagent. So chemical reagent is what? Chemical reagent. What the chemical reagent we will take? So chemical reagent we will take like we have some chemical reagent like lithium aluminum hydride, sodium borohydride, etc. So like suppose we take this is alkyl halide, and we take the hydride ion. From where it comes from? So it comes from lithium aluminum hydride. So lithium aluminum hydride gives you the hydride ion. So this hydride ion, basically an ion. So it will what will happen? This is towards this one, and this hydrogen will get attached to this one. So it will give you the RH plus X minus is like this one. So this is the other method. This is also a method of reduction So this is the different type of method of formation of alkane from alkyl halide. Now we just move towards the next one. Next one we have we can also get it from unsaturated hydrocarbon. Unsaturated hydrocarbon. So what the meaning of the unsaturated hydrocarbon? So unsaturated hydrocarbon means having double bond or the triple bond. So when alkene is reduced with platinum, palladium, ranny nickel, so hydrogen will get attached with by the breaking of the double or triple bond, and it will form alkane. So like alkene is over here, like CH2 double bond CH2 we have, and it will get react with the hydrogen. So in presence of ranny nickel. Ranny nickel is what I told you. Ranny nickel is a very reactive nickel which provides the hydrogen. So it is play a role of reducing agent. Or in place of this we can also use platinum or palladium. So this bond will get break and this will form CH3. So ethane will form over here. Directly you can form ethane. Now if it is suppose we have like triple bond, we have CH3 C triple bond CH. So this is your propine. So again in the presence of platinum or the palladium or the ranny nickel, so this bond will get break and hydrogen will get attached over here. So it will give you CH3 CH2 CH3. So it will be propane over here. Propane. So this is what this one. Now this is also a name reaction. Name reaction is very important. So this is on the Sabatier and Santarens reaction. Sabatier and Santarens reaction. So what the Sabatier and Santarens reaction? So this is the hydrogenation of unsaturated hydrocarbon with a nickel at a particular temperature. So what the temperature is, if we use the temperature just like 523 to 573 Kelvin, so this is known as Sabatier and Santarens reaction. So the reduction of alkene or alkyne with nickel. Now here we will use only nickel so if we just take the alkene or alkyne. So this is alkene, CH2 double bond CH2 plus hydrogen in presence of nickel at 523 to 573 Kelvin temperature, then it will form alkane. So ethane. So this is what Sabatier and Santarens reaction. Again in the similar way, if you use the alkyne like acetylene, suppose you just take acetylene CH3 C double bond, this is the ethine or acetylene is reduced with a nickel at again 523 to 573 Kelvin temperature, then it will give you CH3. So ethane can be formed. Now so this is also, if you remember, you have studied in the class 10th Banaspati ghee. So manufacture of Banaspati ghee from edible vegetable. So edible vegetables are alkene or alkyne, and it forms what? Banaspati ghee, that is the saturated. So ghee is saturated. The ghee which you take, that is saturated. So that's why it is told not to take the ghee for the common man, because common man is what? Who does not do the physical work, because that is the very saturated. So that's why is preferred to eat edible vegetable oil in place of Banaspati ghee, because vegetable oil which you take, that is unsaturated, and this will easily digest and or metabolize by our body, whereas ghee, that is Banaspati ghee, that is saturated and it will not easily metabolize by our body. So it is preferred to eat edible vegetables. Now just move to the next one. Now what the next one is, alkyl halide, we did it. Now from carboxylic acid we can also prepare alkane from carboxylic acid, from carboxylic acid. So how? So there is two way to form. The first one is this is now the decarboxylation method. Decarboxylation method. So what the decarboxylation? D means removal. D means removal, and carboxylic acid means CO2. Removal of CO2 in the form of sodium carbonate is known as decarboxylation. Now, so have a look here. When carboxylic acid react with the alkali, carboxylic acid, alkali is what? Like sodium hydroxide. So it will give you what? It will one H2O will out from here. We can write the H2O just like this. NaOH, wait a second. HONA. So H2O is out from here. NaOH. So it will give me R C double bond OONA. This is the ester, then sodium alkanoate plus H2O. So this is the sodium alkanoate we have. This is the derivative of alkanoate. This is the derivative of carboxylic acid. Now, when this sodium alkanoate, basically this is the decarboxylation. When sodium alkanoate reacts with soda lime is what? Soda lime is NaOH plus CaO. So is the NaOH and the CaO is what? And CaO. So NaOH plus CaO is known as the soda lime. This is what? This is known the both are soda lime. Basically, I just like to hear the soda lime is what? So soda lime is NaOH plus CaO. This is the soda lime. So when sodium salt of carboxylic acid react with the soda lime, so it forms alkane. Na2CO3 is out from here, and it forms alkane plus Na2CO3. Carbon dioxide is out in the form of sodium carbonate. It forms alkane having one carbon less than the original what you take in the reactant which have the number of carbon it have originally. So it have one carbon less. So if the sodium salt of carboxylic acid have two carbon, so the alkane will have the one carbon. So it will form one carbon alkane. Like in the similar way, if you I'm just trying to give you some example over here. So what happens when when sodium acetate? Here the question is, when sodium acetate react with what? Sodium acetate react with soda lime. So sodium acetate is what? This is the sodium acetate. So it's CH3 C double bond OONA, and soda lime is what? Soda lime is NaOH, and over arrow you have to write CaO. So Na2CO3 is out from here, and it will give you CH4 plus Na2CO3. So they can other type of the question they can arise from here, like convert acetic acid into methane. So how will you just use? So there is some steps you have to follow. So first you have to take the acetic acid over here. So acetic acid is just like this. Then you have to react it with the sodium hydroxide first. Then it will give you sodium acetate, CH3 double bond ONA plus H2H, a byproduct. Or further, there is sodium acetate will react with the soda lime, NaOH, and plus CaO plus CaO. So it will give you what? CH4 plus Na2CO3. So the question can be asked indirectly. Conversion of acetic acid into methane, or what happens when sodium acetate react with the soda lime. So you can solve. Now why we use the CaO over here? So NaOH is what? NaOH, only we are using the NaOH of the soda lime in the reaction, because Ca was on the arrow. So what the role of CaO? Role of CaO in soda lime. So basically CaO calcium oxide allows the reaction to be carried out at higher temperature. So it increases that basically it increases the temperature. So CaO increases the temperature to proceed the reaction at higher temperature to proceed the reaction of decarboxylation. So it increases the temperature, and CaO calcium oxide keeps NaOH dry. What the meaning of the keeps NaOH dry? So it keeps NaOH dry, and why this is so? So basically this is a CaO is a quite hygroscopic. CaO is what? Hygroscopic. What the meaning of hygroscopic? Means it absorbs the moisture from the air. So it keeps the NaOH dry. So because it will, if the NaOH will be in a dry position, so it will react efficiently. So that's why. So what the ratio of the soda lime, sodium acetate and soda lime? So the ratio of the sodium acetate and the soda lime is 1:4. So 1 part you have to take sodium acetate, and 4 part you have to take the soda lime. So 1:4 ratio is preferred, and this is also very important one. So this is decarboxylation reaction. This is the lab method of preparation. So you should also keep in mind, because directly they ask you what is the lab method of preparation of formation of methane. So this is lab method of preparation. So you should keep in mind. So this is what decarboxylation is a lab method of preparation. Decarboxylation. Now we can now we have to move towards the next one. The next one is also from carboxylic acid, and that is not the Kolbe electrolysis. That's very important one. Kolbe's electrolysis method. So what the Kolbe electrolysis method, and what you take over there? So this is the electrolysis. Now, so sodium salt of carboxylic acid is electrolyzed with water. Suppose we just take sodium salt of carboxylic acid, like sodium acetate or sodium alkanoate we take, and it undergoes electrolysis. Electrolysis, you remember. So for the electrolysis we need this solution over here, and we take one is the cathode, other is the anode, and if you remember I told you, so red cat reduction takes place at cathode, red cat, and oxidation takes place at anode. Reduction is what? Reduction is gain of electron, and oxidation is what? Oxidation is loss of electron. So this is what red cat and ox phenomena took place in Kolbe electrolysis. So how the reaction will took place? I'll just move towards the mechanism. But first write down the balanced equation for this reaction. So this is the balanced equation we have. Now have a look. I will discuss about the mechanism part of Kolbe electrolysis. So we just take directly an example of sodium acetate. So we just take the sodium acetate. So we just take the sodium acetate over here. This is the sodium acetate, and plus what you take? We take a water molecule. So water molecule. So as you know from this as in the above reactions, so it will form CH3 over here plus 2NaOH plus H2 plus 2CO2. But what's about the mechanism? How it took place? Have a look here. So to see the mechanism, just move to the next. So how the reaction took place, have a look here. We take the sodium acetate CH3COO minus CH3CONA. So it will be get ionized into CH3COO minus plus 2Na plus. Now since water is also over there, then water will also get ionized. So water will get ionized to form 2H plus and 2OH minus. Now have a look here. If you remember, then whatever, if you remember, then I told it have the two cation, two anion. So which is of less discharge potential, that will deposit it first. So over sodium and hydrogen, so discharge potential of hydrogen is less. So hydrogen will take the 2 electron to get convert, will give preference to the hydrogen, and it will get it will deposit it in the form of H2. It will liberate it in the form of H2. So is the gain of electron is a reduction. Reduction takes place at cathode. So at cathode, hydrogen will take 2 electron to get convert. Hydrogen ion will get 2 electron to get convert hydrogen. Now at anode, what will happen at the anode? So now we have again 2 anion. So out of these 2 anion, we give preference to the CH3COO minus, then 2 CH3COO minus. So what will happen? It will come at the unstable stage CH3COO, and it will give you CO2 is out. The 2 molecule of CO2 is out, and this CH3 will get attached with each other to form ethane. So ethane is formed when we take the sodium acetate. This is what? Sodium acetate. So this is the anode is formed. Achha, you should keep in mind where the anode, where the alkane is formed, cathode or anode, then anode. So what happens at anode? Anode oxidation took place. So and what the remaining thing? Remaining what you have is sodium and hydroxide. So this will get combined to the each other to form sodium hydroxide, 2NaOH we have. So it will form just like this. So these are the Kolbe electrolysis. So this is important one. So you should keep in mind. Now some more reaction we have to discuss. So we can also prepare the alkane by the acha. If you want to prepare the methane only methane. So we have the way. So how we can prepare the with this method only we can prepare the alkane having 1 carbon, that is the methane. So how? So when beryllium and aluminum carbide, beryllium or aluminum carbide and aluminium carbide, aluminium carbide react with water so it also forms methane. So this is only the method of preparation of methane only. So individually for methane. So what will happen? So beryllium carbide will react with the H2O and it will form CH4 and beryllium hydroxide as a byproduct. Beryllium hydroxide is a byproduct. Now again, if you take the aluminum carbide, so aluminum carbide Al4C3, then it will get hydrolyzed with water. So it will give you what? It will give you methane. It will also give the methane. So and aluminum hydroxide as a byproduct. Aluminum hydroxide is a byproduct. Now there is one last method to which we can prepare the alkane. That is the reduction of either aldehyde, ketone, carboxylic acid by red phosphorus, hydrogen iodide and red phosphorus. It will ultimately convert into alkane. So if you study about this one, so we will study about this one. So reduction of carboxylic acid, ketone, aldehyde, alcohol, alcohol results in alkane when it is treated with it is reduced with hydrogen iodide plus red phosphorus. So how? Have a look here. Just take some example. So suppose we just take the CS3OH and it is reduced with the hydrogen iodide at in presence of red phosphorus. Some temperature is important. Temperature is 423 Kelvin we take. So 423 Kelvin. So it will form what? CH4 plus 2I2 plus H2O is out. I2, only I2 and H2O is out. And again if you take the some aldehyde like acetaldehyde we take. So acetaldehyde, so how many hydrogen you need? 4 hydrogen iodide we need, and in presence of red phosphorus, so it will give you what? It will give you what? Again what? 2 carbon, then CS3 means ethane plus I2 plus H2O. In a similar way, if you take the ketone CS3 C double bond acetone, we just take acetone and hydrogen iodide in presence of red phosphorus at 423 Kelvin temperature. So it will form 3 carbons alkane. So CS3 CH2 CS3 plus again it will give you 2I2 plus H2O as a byproduct. And in the again if you take the acetic acid like CS3 C double bond OH plus 4HI. So HI is and the red phosphorus is very powerful reducing agent. So it reduces everything into alkane. So this is everything means alcohol, aldehyde, ketone, carboxylic acid into alkane. So it will give you CS3 that's ethane, and plus what? How many I2? So you have to take here the 6HI, then it will give you 3I2 plus 2H2O. So these are the different type of reaction for the preparation of alkane. Now I'm just going to make a flow chart for you for the preparation of alkane, which you have to keep in mind. Let's start for the making a flow chart. So this is the flow chart I'm going to make over here. So what we take alkane over here. We have to make alkane. So this is the method of preparation of alkane only. So now let's start from where we have started. We have started from alkyl halide from Grignard reagent. So RMGX when treated with water, so it gives you alkane, or RMGX when treated with alcohol, CH3 which you have taken, so it also gives the alkane. And again where we have the alkyl halide react with sodium metal in presence of dry ether. So this is known as Urge reaction, WURTZ, Urge reaction. So this is also what? This is the third method of preparation of alkane. Now again we have the Corey's house. Corey's house have alkyl halide. This is for the symmetrical and unsymmetrical both. So alkyl halide with lithium and copper iodide, it will also give you alkane. So it is a very good for this is not the Corey's house, COREY, Corey house, 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 and reaction. So Corey's house reaction is for both symmetrical and unsymmetrical alkane. Now again alkyl halide can be reduced with zinc and HCl. So this is also the method of preparation. And again we can use the alkyl halide when it is reduced with the palladium or platinum. So this is the catalytic hydrogenolysis. So again when alkyl halide react with the lithium aluminum hydride or sodium borohydride, so this is the chemical reagent where the hydrogen hydride ion is used. Now we can also use the alkyl iodide with the hydrogen iodide and plus red phosphorus. So it will also give you what? Alkane. Now again from carboxylic acid, there is two methods. One is the decarboxylation, first with the sodium salt of carboxylic acid with the soda lime. Soda lime is what? NaOH plus CaO. Soda lime is what? NaOH plus CaO. Soda lime is what? Good. So this is known as the decarboxylation. Decarboxylation. So this is the decarboxylation reaction. Again we have Kolbe electrolysis. This is the electrolysis of sodium salt of fatty acid. So this is the electrolysis, and we should keep in mind this is the Kolbe electrolysis. So name reaction we have to write away. Wait a second. Electrolysis happens. This is the name reaction. This is the Kolbe electrolysis. What the name is? Kolbe electrolysis. Very good. Kolbe electrolysis. Now, the next one we have, it can also be prepared. How you can prepare it? We can also prepare, if you want to prepare only methane, then you have to take beryllium carbide. What? Beryllium carbide, and hydrolysis of beryllium carbide gives you methane only. And the aluminum carbide is what? Al4C3. Hydrolysis also gives you methane. And the last but not the least, this is what? This is, we can take either the alcohol, aldehyde, ketone, or carboxylic acid. So it will get reduced with red phosphorus plus Hi plus red phosphorus. So Hi plus red phosphorus will give you alkane. So this is all about the preparation of alkane. So how many? So let's start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So overall we have 13 method of preparation for the alkane. So now this way we have covered the preparation of alkane today. In next class we will study about the physical and chemical properties of alkane. Till then, goodbye, take care.